Okay, question number 9, here we go. So I have which of the following series converge? Now I'm given 3 series, I'll just go ahead and do them one at a time. So let me start with this first one. So this one is a ripe candidate for the ratio test, so let me go ahead and get started with the ratio test here. So if you'll recall, I'm going to take the nth plus 1 term and then divide it by the nth term and see if the ratio converges to some finite value. So what I'm going to do is I will have 8 to the n plus 1 over n plus 1 factorial, and then I'll have to divide that by 8 to the n and then n factorial. Now sometimes it can get a little bit messy trying to simplify this down, so let me just walk you through step by step. So I'm going to split up this fraction, so I'll have 8 to the n plus 1 over n plus 1 factorial. Then I'll multiply that by the flip of this bottom part of the fraction, so it'll be n factorial over 8n. So I'm going to get a cancellation of the 8n's, and this is going to simplify down to 8 times n factorial over n plus 1 factorial. Now this is where a lot of times people get confused because they don't know how to simplify the factorial. But one way to think about it is look at like any number, right? So maybe 3 factorial. So that's going to be equal to 3 times 2 times 1. So the way that you would do that is you would just imitate it within kind of symbolically though. So it would be 8 times n multiplied by n minus 1 multiplied by n minus 2 and then dot dot dot, right? It keeps going on forever. So then you do the same thing for the bottom. So I'm going to have n plus 1 and then I'll have n plus 1 minus 1, which is just going to be n, and then n minus 1, n minus 2, and so on for infinity. Now, what happens is all these n's cancel out except for this first term, and I will be left with the limit as n approaches infinity for 8 over n plus 1, and I know that this is going to converge to 0. Therefore, by the ratio test, 1 is going to converge. So that's getting a check mark for me. So let me go ahead and erase everything here, and we'll go on to the next series. Now, the nice thing about the next series is that, well, let me put it this way. You could do the ratio test, or you could just kind of, how do I say this? You could kind of logic your way through it using the limit test. So I know that if the, you can try the ratio test, but I'm going to kind of think about this conceptually. So I know that if the sequence, I'll just say it. If the sequence converges, if the sequence diverges, the series does not have a single chance of converging. Okay, the series is definitely going to diverge if the sequence converges or diverges, right? Okay, so I just want to see the limit as n approaches infinity for this sequence. Does that converge or diverge? I think it's an interesting question. But what I'll tell you is that a factorial will always beat a exponential. Well, almost always, right? There's some exceptions to this, but especially whenever it's a fixed exponent like this, the factorial is always going to beat it, right? Maybe not at first, but eventually it will catch up to it. So this is actually going to diverge. So this is the, what do you call it? I think it's called the nth term test. Because it goes to infinity, it's going to diverge. So 2 is definitely out. So this actually gives us anything with 2 in it is already out. So, maybe it's process of elimination if you have to. All right, so now for the third series, I guess one test that we can use here is the direct comparison test. So what I'm going to do is go ahead and write out this series, and let's just take a quick look at it. So I have n plus 1 on top, and then n plus 2, n plus 3 here. Okay. Now, I just want to figure out what power of n is the highest power we can get if I was to factor out everything on the bottom. So if I do that, I'm going to get a degree n of 3, and then on top I have a degree n of 2, oh sorry, not 2, 1. So I'm not even going to factor it out. I just know that the largest exponent of n on the bottom is going to be n to the third because I have three n's and they're multiplied together. So hopefully logically that kind of makes sense. Now what I can do is I can say, all right, compare this to, I guess, I think it's b sub n. You know what, here, I'm not even going to use those terms. I'm just going to say, look, think about this logically. So I'm going to say compare this to a p series 1 over n squared. Now this one, so I'll say which converges. Okay. So if I have this, this is going to converge. Now this comparison is 100% always going to be greater than my initial one. Now you might be wondering why that is, and the reason why that is because I have more terms of n on the bottom, and if I have a bigger denominator, I have a smaller number. So large bottom equals small number. So for all values of n, right, this one's always going to be greater. And if this one converges, it logically follows that the one that's smaller has to converge because they act in similar ways, and it's always going to be smaller. So what that means is that by the direct comparison test, this one should converge. So therefore, A is out, C is out, and our only answer choice left is D, which is in fact the correct answer. Hopefully that makes sense. If you have any questions, feel free to comment below, and I'll see you in the next video.